I've already discussed translations, so now we're going to move into rotations. Rotations has a specific rule that we need to follow to be able to turn different shapes amongst a coordinate grid. So the orientation, the way that the shape is positioned on the graph is going to change, but the size and the shape of the picture is going to actually stay the same. So my rule that I'm going to explain in just a little bit, we need to know that it's going to be y, comma, negative x, or opposite of x. I know this rule has no, you don't know how to use this yet, but I'm going to show you by doing this example with you. So if we had an example like this, I would be asking you to rotate the triangle 90 degrees clockwise. This rule that I wrote up here is specifically for a 90 degrees clockwise rotation. So this is the rule that we're going to be using, and I'm going to show you how to use it here in a second. So looking at this picture, my first step is I'm going to identify all of my coordinate points. So I have J, which is negative 5, 4. I have L, which is negative 4, 1. And then I have K, which is negative 2, 3. Okay, so my goal is to create a 90 degrees clockwise rotation. That means that I'm going to take this triangle and I'm going to move it 90 degrees clockwise, which is a right turn, and it would be turned into this quadrant at the upper right. So in order to do that, I need to use my rule to work on changing my coordinate points. So using my rule, the way that we talk about this in class, I give it a random phrase so you can kind of remember it. We're going to flip-flop. So we'll flip-flop the variables because normally it's an XY pair. So we're going to reverse the numbers around, so flip-flop them. And then we're going to change the X to its opposite. So in class, I might say flip-flop X op, and that's just a way to remember that rule. So doing this to my first point, I'm going to flip-flop my numbers. So the 4 would come first, and then this negative 5 would change to its opposite. So negative 5 and the opposite of negative 5 would be positive 5, and that would be my second number. Same thing for the next point. I'm going to flip-flop the numbers. So my 1 would come first, and then this X value is going to change to its opposite. Flip-flop and then X to the opposite. So I have positive 4. And the last one, my 3 would come first. And then I would change my X value to its opposite. So flip-flop X op. So this negative 2 would turn into a positive 2. So these are my 3 new points. And if I plot these points, I would have 4, 5, 1, 4, and 3, 2. Once I connect those, I can see that it is the same size of shape, but rotated 90 degrees clockwise. So obviously 90 degrees is not the only degree turn that we could be doing. We could be doing a 90 degree, we could be doing 180 degrees, or 270 degrees. So all of these would be my clockwise motion, and I have to tell you the rule for each of these. So we know that 90 degrees clockwise is the flip-flop X op, what we just talked about. 180, if I did a 180 degree turn, that would mean that I would have to do 2 90 degree turns. So that means I'm going to do the rule 2 times. I'll do an example here in a second to make sure this makes sense. And then if I have a 270 degree turn, so if I did this rectangle, one turn would be 90, another turn would be 180, the third turn would be 270. So I would have to do this rule 3 times. So let's practice this on this bottom problem. Change a pin. All right, so my first step is to identify all of my points. So I have A value, which is 2, 4. I have B, which is 4, 4. I have C, which is 4, 1. And I have D, which is 2, 1. Okay, so we are going to be doing a rotation of 180 degrees clockwise. So since it's 180 degrees, that means that I have to do this rule 2 times. So I'll do it the first time. The first time I do it will be just for a 90-degree turn, but I don't want 90 degrees. So I flip-flop these. So my 4 would go in front. My 2 would turn into a -2 because it's the opposite of that number. For this, if they're both 4s, it doesn't really matter, but I know that the second value needs to be negative because my first 4 is positive. Then I have 4, 1, so 1 needs to come first. This 4 needs to change to its opposite, so it will be -4. And then my last one, I would have 1, and then my 2 would turn to its negative. So all of this, if I plotted these, it would show a 90-degree turn in this bottom right quadrant. But I don't want 90 degrees, I want 180. So that means I have to do this rule again to my new points. So I'm going to ignore my original points because these are my new ones, because I've already turned it once, I need to turn it again. So I need to flip-flop X up. So flip-flop, so that means that my -2 is going to go in front. And now my 4 is negative. For my next pair, my -4 is going to come out in front. And then my X is going to change to its opposite, so it'll be -4. When I look at this next one, I have -4 out in front, and then my 1 would turn to its opposite. And my last one, I would have -2 out in front, and then my 1 would turn to its opposite as well. So these are the values. All of these 4 points are the ones that I would be showing for a 100-degree or 180-degree rotation. So when I plot these, I would have -2, -4. So here's my A. I would have -4, -4. Here's my B. The next one would be -4, -1. So that's C. And then my last one would be -2, -1, which is D. So when I look at this, I can clearly see that it rotated because the order of my points are different. So my orientation changes because the order of my points changed as well. This looks, if I looked at it really quickly, it looks like a translation. It looks like I just brought this down and slid it over. If I did that, then this point and this point would be the same. And since they're not the same, that tells me that I know for sure that this is a rotation. On
electives, you're dismissed.
The very last step.
Mr. Robert, if you're in the building, could you please come to the office?
The last step for this table is talking about counterclockwise. So clockwise means that we're turning to the right. Counterclockwise means that we're turning to the left. So counterclockwise, 270 is the same thing as 90. 180 is going to be the same no matter what. And then my last one is 90 degrees. So if I were to ever ask you, well, what's the same thing as a 90-degree counterclockwise rotation, you could tell me that it would be 270 degrees clockwise.